First of all, well, my name is Montserrat Pérez Moya, and I'm coming from the Universitat Politécnica de Catalunya. I put this slide just to don't forget to tell thank you to the nice organization of this event. I think every year is better and better, the European Summer School. So thanks for the people who is coming and for the people who organize. I would like to show you also the place. I am from University Polytechnic of Catalunya. We are in different buildings, and now we move to some area near, if you know Barcelona, near where it was the forum. So we have new labs and new area, and you are welcome to visit us. So I put the links of our group and our school. And let's go now to the talk. So they were asking me to talk about optimization, and I thought that it was important to make a little talk a little about modeling, because when we would like to optimize, first of all, we need some model of the system, of the reality. So for this, I will start with modeling. I have the feeling that in all the talks we listened today, already the word model, simulation, was appearing in a lot of different contexts. So I'm going to talk in a very simple way, just to understand the concept. Yeah. So mainly, what is a model? Why we need to know about estimation, kind of modelings, and then I will go deep to optimization. Okay, what is a model and why do I want a model? Already also disappeared today too. Why we need the things, no? Why we make the measures, which measures we need for what? Why there are so many different models, and why do I want models with different levels of detail? It depends on which purpose are behind. So I make just a little fun, and to make a comparison, I wish to travel to Campinas. Maybe this year better to Natal, but already I have the presentation. So July 2019, and my question is how I will go to Unicamp. Okay, so I know that it is in Brazil, so at least some information. And first, I take a look of some map. But if I take Cantino 15.2, even is not there. America, in Mercator 1595, neither. Here it's already appearing, and in 1820, even with more detail, and in this one, more detailed. So some thoughts. What is a map? For what is useful a map? Which is the relation between these previous maps and the following graphics I'm going to show you. This is the first graph. What I have here, so I have some measures, maybe I have done in the lab, and I correlate them with some linear regression. This one looks better, more data is there, yeah? I make more experiments, but sure, more experiments, more cost, more time consuming, more resources consuming, but I have quite better information about my system. Even now, I am able to detect some data or some experiments that maybe were not so much good, and I am able to refine my model, and I have better correlation. So, what is data? Data is information. What is a model? Model is a structured information. In what we use this model? To do predictions. What we want, we have our system, and we make a lot of effort to modulate them. And what we would like to modulate to later don't need to go to there to measure again. What we want is later, with the model, be able to simulate a lot of different situations and know the answer. Why? Because we would like to make decisions. We would like to make the decision if I stop the treatment now. We would like to make decision if I combine this system or this treatment with another. So for which things we would like to have models. It allows to predict the behavior of a system, a model, based of variables which influence if the system behavior. This is another important thing. We have a lot in our treatments that we are working on patient oxidation processes, a lot of variables that are affecting to the system. It's impossible to check all. So another important thing is which ones are the more influenced. When I decide the model, which ones are relevant for me. So the system already, this one is more simplified. It was quite more complete and nice, the one of Marugan, but it's the same, input and output. And what is in the middle, the system is a black box. And this is what I would like to know, some equation, something that I am able to explain what is happening inside that black box. So then a model is a representation of the reality. Could be some maqueta, but in our cases, a lot of times it's just something abstract, some mathematical equation, some computer program is what mainly we are having. Okay, but why we don't have the reality? Reality is better, no? But what I will do to go to Brazil, to go to Campinas with this picture that is reality, it is useful for me. Here that is quite more information because this is a reality. What purpose does it serve, the reality? Sometimes something more simplified is more useful for our purpose. So, if the world is one, why are so many maps of the world and are so different? Because we have maps for time zones and maps for extension and maps for capitals and maps for other things. Why for the same phenomena, not only for now that simulation of my traveling, may exist different physical models? Ptolemeu model, Newton model, Einstein model, and so on. Which model is more appropriate? When we are going to check the literature and we found a lot of suggestions for our system for advanced oxidation process, which is more appropriate? Which one I need to choose for my special case? Let's go to keep the example. I go to Brazil and I already know where is Brazil. And now I need to know where is Campinas. So I have the region of Campinas inside the Estado de São Paulo, situated. And then I need to find the roads to be able to arrive there, but they are waiting me in some office. So I need more information, more detailed information. And at the end, with this last, where is written even the rector cabinet, I will be able to arrive to my place. So partial and limited representation of the reality. These are the model. Always are partial and limited. They should be appropriate to the purpose that we have. So if I would like to go by car, I need some map of the roads. Many models, no one is good enough. This is the reality. No one is good enough. For this we are following, studying the system and following and deciding models. When we will have the definite one, maybe we stop with that, no? But they can be valid if they allow sufficiently accurate predictions for our needs. So what is my need in some process? So this is something that I need to ask myself. My need is to stop the experiment when already I am sure that it's not toxic. Okay, so I need a model that is able to make this prediction. And the other things I don't mind. The other variables I don't take in account. But they can be valid if they are for our needs, so we will decide then if we take a general, a concrete, a simple, a complex. Is software better a complex? Already I think the answer is not. What is here is some question for you. Which one is the right one? Model A or Model B? Model A, someone stand the hands for Model A? No one? Model B? Neither? If I would like to know the volume of 1 mole of water in standard conditions? Someone tell A or B? Someone tell B there? So what is this slide for? Oh, let's go to fill it. Maybe let's go to follow. Sometimes we make modeling errors. We select not the good level of detail, or we take even a totally mistaken map. This is what happens there. First one, A, is a model that everybody know it, and is very familiar for us, but is a model for ideal gas, is only for gas at high temperature and low pressure, and do not describe liquid vapor equilibrium state, and even less at these conditions that we talk. So, what is the problem? The models are not burning us when they are already not valid. So we need to know not only the model, if not only the rank of validation of that model. So if you create a model, you need to specify it in the paper. But if you read a paper and it's not clear, so you will need to look for more information, but you could not use it. So this is the problem, that even this is a right equation, maybe it's not valid for the purpose that I am using it. So also I need this. I will go very fast in this part because I only put it here because it's related with what I told you. For what is important to have estimation? Estimation is important because sometimes I need to know what I should expect the answer from my model. So I should make some little estimation of what I think it will be the answer. And this will help me to realize if I am in a totally wrong situation. So, what type of model did we use when we make an estimation? I will make some fast example that if we will have time, I will make you to do. So you will have it there and you could make it at home if you are with the taste to do. The question to solve in 60 seconds individually will be to answer, look around this room and tell me how many ping pong balls could fit in this room. If you will have just 60 seconds, I guess the mind of the answers, because we don't have time for this, will be related with answers like lots, thousands, yes? Or maybe someone will take no idea, but anyway, it's better tell lots, thousands, that don't tell anything, because already lots and thousands and some category difference that tens or zero. Yes? So, what is, this will be some categorized answers. So what is the point? We have only 60 seconds. 1 second. If we will have, instead of 1 minute time, we will have 5 minutes, I'm pretty sure that you will start to think about how it is a ping pong ball, how to take advantage of the measure of this room. You will make some fast route calculation, and you will get more near to the right answer. Yeah? So you will estimate better. No? So, for example, you will calculate estimate the room, estimate the ping pong, yeah? And you will decide, you will take some decisions. For me, it's a cube, for me, it's a sphere, and so on. You will decide if you will take advantage that here are some tables or not. It depends on the times you will have. So then you will make simplifications and assumptions. This is also what we make when we are modeling. We are making simplification. We are taking some variables that we think they are less important to get the final answer. Yeah? So also we will decide if we are able to press the ping pong balls or not, or we will take advantage. So second part of exercise will be this. I let you 5 minutes, you will be in couples, and you will discuss all these things. And what will be the next steps that sure I will answer you? I will answer you. You change already the way you were modeling the answer? I'm almost sure yes, because you have more time, you have more possibility to make a calculations. Yeah, and this time you were sharing the task, you were having similar ideas with the people that you work, and what I would like to I go fast on this, is that this sentence. The design of a model depends as much on circumstances as constraints. Sometimes we have to finish a PhD. Sometimes we don't have money for make some measures and not another. Sometimes the answers are also around some constraints to solve the problem that we need to take in account. I am going to show you here that also there are some another, when we are deciding to build a model and we need to select the right variables, sometimes it's like we are making some caricature. We are just taking the features that are more important to show that model, or the ones who are more relevant for the objective that we were marking in our work. Okay. Here I would like to show you also that another, if we will make the decision to decide that the ping pong balls will be in this way, atomic packing factor 0.68 because it's cubic centered, and we will, instead of that, decide that they will be cubic centered with a packing factor 0.74, we will solve it in these two different ways, we will have a totally different answer. In one case, we are going to take, we will have the lower bound of the answer. So when we make an estimation, it's also important to think which simplifications I make, and these simplifications are going to give me an underestimation or an overestimation of my solution. Because this will later help me when I use my model to see if my value is inside the upper and the lower bound, and if I could believe or trust in this value. Yeah? Here you will have the calculations. Here it is the, we decide that we are going to make the calculation that is not air gaps. So if it's not air gaps, then I will have the upper bound, because the reality is that there will be less ping pong balls that if I, because the air will take some space. So this will give me another number, and when I am dividing upper bound and lower bound, I have a number that is telling me that my model is 50% accurate because my value is 2. Yeah? So it's important to keep in mind this part to know the resolution of my model, the resolution of my the model that I propose for my solve my system. Okay, this is a little about model, variables, parameters, constraints, estimations, upper and lower limits, and now let's go to the main subject, that is optimization. Why do I want to optimize, and how I can ensure that I take the best decisions? Okay, what is optimization? Optimization is a mathematical technique. It's something systematic that gives support to decision making. Have not any consequence that I optimize in my lab, that I make some calculations. Have not any risk and have a little salary. But sure, decision making already is a personal action with consequences, and for this, the persons who are in the companies taking the decisions have risk task and good salary. Yeah? So, we will let something that is risk to the intuition? I don't think so. I think we will need to put the effort necessary to determine the best decision. But what is the best? We require a representation of reality, that already we know that this is a model. We require also something to quantitative assessment this model or this system. So this is the objective function that could be what I told previously, that it will be any toxicity, or will be that is the more efficient, the less time consuming for get to more degradation or whatever. And we need a search method, that this means an algorithm. Yeah? So this is the three more important parts for do an optimization. Let's go to see the objective function, because we already talked a lot about models. The objective function is how to quantify the subjective assessment of the system answer. Allows you to better discriminate between several possible alternatives. Yeah? For instance, you need to buy a new car. What is the best car, and why? Which is better, a Porsche or Ferrari? Why? Yeah? Let's go to move back to mathematics. Here we have, for instance, we need the meaning of XE, the variables, and AB, the parameters. We have the constraints, equal and equal, and this is more or less how it looks, a mathematical representation of optimization. The search method, it will be an algorithm. It's not so easy, but it's true that every time more we have a lot of possibilities, a lot of programs who help us in this, to check with different algorithms to optimize the solution. But a very important point is to guarantee of optimality. The optimum, it is the best solution that was found, or is the best solution that is possible to find? It is necessary to ensure that has not sense to follow searching. So when we are writing in a paper that we have found the optimum, means that this is the best. If we are not sure that is the best, that if it's only the better one that I was able to find, then it is the best solution that I am able to find, but it's not the optimum. So when I am telling that is the optimum, I'm telling to the world, don't follow searching. It's nothing best than that. Yeah? So let's to look in a mathematical way. I have these measures, and I have these constraints, yeah? And I think that this is the appropriate model. Yeah? So then, if I will optimize, and I would like to imagine that this is the cost, I would like the minimum. I will think that in some place here is the minimum value for my model. But this means that this is the model. But if it is that, the model, if I'm not sure, and if with these measures I am found it, I make the algorithms, and if he found me the minimum, he will tell me that. But if the function is another, I will be totally mistaken, and my global minimum will not be the best. It's possible then to tell, no, in the next paper, okay, now I make a refine of my model, and I found a more optimal result? No. This one is a better optimized process, a much better? No. Yeah? So here I also let you some exercises that, for instance, imagine you need to optimize the size of the Coca-Cola can. So what it will be the model, the objective function, and the way to search the method. Because this one, I would like just to show you very fast. Later you take a look in detail. Because focusing now in the search method. Yeah? Why? Because very fast, I think you will very easy to understand. I am just deciding, because I need to take the decision what I am going to optimize. The one that will be better for me will be the one who needs less material to fabric, because we'll have less cost. Yeah? So then I am calculating areas and volumes, and I decide that the cost is the objective function. Here you have the equations, and I will use infinitesimal calculation. Again, we are going to something that is very common for us. This is the first that it comes to our mind when we talk about optimization. Okay, in this case, it's right. But take care, because if the only tool you have is a hammer, you tend to see every problem as a nail. And in this case, this is, I could use this, and I could guarantee, but only in this case, or in this kind of situations, because this is a function that is continuum, that is derivable, and that has not another minima. But if I could not be sure about this, I could not use infinitesimal calculation. Yeah? Again, here I could not use infinitesimal calculation because I have more than one minimum in this area. Yeah? here I would like, I don't know how many of you are using response surface models, but again, response surface models have a problem that are pressing us to use first order model or second order models. And a lot of times, if we are, for instance, putting them in some, this is not real experimental values, so they are just generated like equation, like a kinetic of first order. And in early reaction times, if there I am using my design of experiments and I am pressing a second order equation, it's fine. I get a good answer for optimization. But what happens here? I have a wider span, and the model is a second order, is pressing me to have a minimum, and this minimum is not real. This is something that is telling me the model, and later the optimization is bringing me here. But my system is not behaving like this, it's behaving like that. So if I don't see the reality of my system, and I choose a wrong model, then I make all the process correctly, but I am going to some wrong answer. So I just tell you that you have 2 examples more about not infinitesimal linear optimization. I think my time is gone, no? So you could take a look, and if you have later some questions, I will be around here, like another kinds of cases that are not so simple.